Hello, everyone, and welcome to this webinar for the Southern Plains Drought Early Warning System. My name is Joel Lisenby. I'm the coordinator for the Southern Plains DEWS. I'm based at the Cooperative Institute for Research in the Environmental Sciences at the University of Colorado in Boulder. I also work for NOAA's National Integrated Drought Information System. I'm really glad you're here. Today is going to be a pretty fun webinar. We're going to talk about a report that was published in partnership between NIDIS and the Southern Plains Drought Early and the Southern Regional Climate Center on an assessment that we did for the 2020 to 2025 drought. Go ahead to the next slide. So this webinar is being recorded, and so you can, after we're finished, it'll be put online at both on NIDIS's YouTube channel and at drought.gov/webinars. And all of the attendees are muted. If you would like to ask a question to the presenters at any time, you can type that into Slido. Those of you who joined this webinar on a browser, to get to Slido, you need to click on the Apps button first, which is down in the bottom right of the WebEx display. But those of you that joined on the WebEx app, you should be able to see the Slido app, the Slido button right there in the app. Go ahead to the next slide. So I'll introduce the speakers. I'll be doing part of the presentation today, and also BJ Bowley from Texas A&M and the Southern Regional Climate Center will be taking on the other parts of the presentation. We're going to do a bit of a tag team throughout. It should be lots of fun. Go ahead to the next slide, BJ. So first, those of you that may be new or haven't heard of a drought early warning system before, I want to explain this just a little bit. So a drought early warning system is a regional system that helps improve the capacity of land and water managers and other decision makers within that region to help them plan for, forecast, monitor, and cope with the impacts of drought. This is accomplished through a network of partners, and we all work together on this shared goal of preparing the region for future droughts and to help be proactive when it comes to managing drought risk. Click the button once. I've got a circle that will show up on this slide. So I coordinate the Southern Plains Drought Early Warning System that covers the states of Kansas, Oklahoma, and Texas. And that's the region that we focused in on in this drought assessment we're going to talk about. Go ahead to the next slide, and I'm going to pass it over to you, BJ. You're welcome to say a little bit more about as far as an introduction of yourself, and tell us a little bit about the Southern Regional Climate Center.
Yeah, so hi everybody. Excuse me, this is BJ Bowley. As Joel mentioned, I'm with the Southern Regional Climate Center and am located at Texas A&M University in College Station, Texas. The Southern Regional Climate Center, we're one of 6 regional climate centers throughout the country. Each of those serve their respective regions. Ours is the state of Texas, Oklahoma, Louisiana, Arkansas, Mississippi, and Tennessee. And basically what the RCCs do is we distribute climate information and try to provide climate services to make that data that's out there, that's been collected, funded by your tax dollars, and make it more useful to you, the end user. So that's what we do. The SRCC did start at Louisiana State University over in Baton Rouge in the 1980s, and it moved to Texas A&M in 2021. So to summarize, our goal is to serve usable climate information to stakeholders in NOAA's southern region. So a little bit more about this drought assessment and the process that we went through. So drought assessments, they do serve a value and a purpose. Those are to help understand how droughts evolution and impacts. So understanding that, and then taking that information and communicating it to decision makers across the region. That's who we hope to reach with this report. It can inform future drought risk management and mitigation actions by analyzing drought hazards and exposure, impacts and responses. And then we're trying to share best practices from our region and from lessons learned from other regions and local insights from stakeholders to better prepare our region for future droughts. Like I said, this was a partnership between the Southern Regional Climate Center and NIDIS. So they provided some funding, and we drafted the report and went back and forth a lot with each other and stakeholders in reviewing and getting this out. We got a lot of feedback from our federal, state, and local partners. And we're going to move into kind of what we did to get this information, because drought information isn't always readily available at the surface. It can come from a lot of different sources. So trying to synthesize and process that information is really important. So when we looked at first at the report, we needed to see what was out there and what had already been done in context for the Southern Plains, other regions as well. So specifically for the most current drought, 2020 through 2025, this included synthesizing about 5 years of emails about drought impacts. We're both part of a list and a group of people that send drought impacts and updates every week. So we took the last 5 years of those and synthesized that information together for the southern region to get a picture of drought and how it was communicated through that. We also compiled and discerned a lot of information from media reports. A lot of the impacts and things that you see from drought throughout the region are communicated through media reports to a lot of folks. So we did go through that. We also looked at historical weather records to put this drought in context of previous events and just how bad was it. We also got information for the southern region from some of our old webinars and drought status updates that were done during the drought to see what information we had when, and get that full picture. We also went through each state's records and documented gubernatorial emergency declarations for each state in the Southern Plains. So what those are declarations made by the governor that generally declares an emergency. It authorizes certain agencies to do their jobs and taps into funding resources for them. So that is an idea of how the government responded to the drought. So we did that as well. In addition to looking through past reports and a lot of the information that was already out there, we did engage stakeholders directly across the Southern Plains region. We conducted what we call listening sessions. What these were a series of webinars where we just had a initial kind of stage setting presentation, what we were talking about, the drought, and then asked folks to share their stories about what the impacts that they saw in their operations, in their locations throughout the region, and how that affected them, how have they attempted to recover from that, both in the past and with the present drought. A lot of the information that we heard from stakeholders were really about the successional impacts of drought, or kind of how drought impacts pile up or snowball on top of one another. So the region suffered a pretty severe drought, particularly West Texas, eastern New Mexico was really bad from about 2010 through 2015. You saw a lot of drought impacts from that, low river flows, reduction of livestock herds, crop failures, water shortages. And see how, and they had that in that period. And then, so you have to recover. It's not necessarily a linear process. So they were already recovering or trying to recover from the last drought and hadn't really finished recovering. And then they got hit with another drought again. Some quotes from that is, "The land is sick. It hadn't had time to recover yet," from that 2010 through 2015 drought. We heard this kind of over and over from different stakeholders in a lot of different areas. So moving on from that, another part of the project that actually didn't make it into the full report, but it was in the initial call, and we are submitting this for a peer-reviewed journal article here soon with John Nielsen Gammon, the Texas State climatologist, Joel, and myself. We wanted to see how well the 2025 through 25 drought was captured by forecasts. So we did the North American multi-mean ensemble, so kind of a grouping of different climate models. That's what's on that picture at the right, our different drought forecasts through time. Each color represents a different model that was used to forecast this. And we wanted to see how well those did. So what utility do our current forecast models have in forecasting drought for the Southern Plains? Kind of just a way to quickly summarize that. So kind of as expected with forecasts, generally the closer you are to the event, the better the forecast tends to be if you're doing the forecast correctly. So shorter lead times did offer more skill than longer lead times. That would be like an example of a shorter lead time, a half a month on 6-month total precipitation accumulation. So some of that period already happened, and what was going into that last half month would have been predicted by the model. So that short lead time were more skillful than longer lead times. They did forecast fluctuations in drought conditions, but the forecasted fluctuations lagged the observed fluctuations in drought conditions, so the model wasn't picking up on it quite quick enough, would be one thing from that. As well as forecasts in the southern part of the study region were more skillful than in the northern part of the study region. So South Texas had more skill than northern Kansas. And models were generally determined to be overconfident in their predictive powers. So those are kind of just the summary of that one aspect of the report that didn't make it into the final. But we wanted to bring that out because we think the information is useful. Be on the lookout for that to be published, and we can probably send it out over a list when it is published as well, similar to the invite for this webinar. So moving into the report itself, the Southern Plains Drought 2020 through 25. What happened? So moving into that. On the screen there is a drought progression map. So what that is the United States Drought Monitor for each week or each month from 2020 through early 2026. We have January 26 down there. And what that shows is the Southern Plains region, which are highlighted in bold on each map, and then the surrounding states. We show that information from January 20, and we can kind of see the drought settling in. You know, we kind of start early 2020 with drought in South Texas, some in Colorado and New Mexico, waxes and wanes a little bit. Over the year, sets in again in the back half of the year, kind of peaks winter 2021, and we see it kind of roll off in 2021. That drought peaked in Texas and Oklahoma during that time. As we moved more into 22, 23, in 23, we see that drought peak in Kansas and then Louisiana later in that year. The flash drought of 22 or fall 23 really affected East Texas and Louisiana, where you see that dark colors over here on the right, 2023. Moving into 24, we saw it easing off a bit. And then the back half of the year, drought worsened again. In 2025, we saw drought really return to West Texas and make itself known there and really settle in. And then moving into this year, we are seeing an uptick in drought conditions. It's been a dry winter, and most of the region is experiencing some level of drought at this point in time. So to get started with the report, we first had to define what a drought was to get the beginning and end. There's a lot of different definitions of drought. There is no one size fits all definition. So we kind of had to put our heads together and figure out how did we want to demarcate the beginning and end of this drought. So we chose to use something called the Drought Severity and Coverage Index. It's an indicator that's based on the U.S. Drought Monitor, essentially accumulates points for drought over scale and then over space, and then also how severe that drought is. More severe, more spatial drought is going to end up with a higher drought severity and coverage index. So we looked at the drought beginning when these drought severity coverage index values remained at a value over 100 for the Southern Plains region for at least 12 weeks. So that really led to the drought starting in the first period is June 2020 is when that first threshold was met. And the drought would end when the first week of a 12-week stretch, once those drought severity coverage index values fall back below 100. So on the right is one picture of the DSCI values for the Southern Plains on top from 2000 through present. The current drought is highlighted on the far right of that. We also see the 2010 through 2015 drought there right in the middle. As noted, the Southern Plains DEWS was created in early 2011. So that's when the Southern Plains DEWS came on the scene. That was the last significant drought in the state. But what that resulted in, there were two distinct drought periods from 2020 through 25. That first one, like we said, ran from about June 16th through June 8th of 21. In summer 2021, we were largely free of drought, but then in the fall of 21, we remained in drought conditions again through June 8th of 2025. And again, if we wanted to look currently at the last few months, we're back in a drought in the Southern Plains. So it may have just been another pause in the drought looking out to the future. But that ran through June 2025. So initially, like we said, starting in summer of 2020, we saw that spring precipitation patterns had shifted east over the region. So the west and the northwest had that precipitation anomaly. You can see that on that April through September 2020 precipitation anomaly on the screen there. Arkansas, Louisiana, East Texas, Deep South Texas all saw positive anomalies. The rest of the region was dry. But as we go to fall, you saw improvements in South Texas and Yeah, summer 2020 over West Texas generally tended to be hot and dry. You can see the drought monitor as of September 29th, 2020, showing exceptional and extreme drought in West Texas, eastern New Mexico, up into western Colorado there. As we moved into the fall and over the winter of 2021, we really saw drought dig in far west Texas and eastern New Mexico. You can see on the drought monitor map from December 2029 or December 29th, 2020, that large expanse of maroon and red kind of spanning from central Texas out to the northwest across the region. That's where we really saw drought dig in during that winter. Droughts in the Southern Plains are often associated with La Nina events. As you can see there, that's a plot of the Oceanic Nino Index, or ONI. You can see on the top there, that would be when we see an El Nino event. That's when the ONI is over 0.5 degrees Celsius above normal. La Nina is the opposite, when it goes 0.5 degrees C below normal and stays there. So if we look at late 2020, that was a fairly significant La Nina event, bottoming out about -1 or a little greater than that, or less than that. It's going negative. And what's generally associated with La Ninas in the Southern Plains is a warm winter and dry conditions. You can get cold outbreaks, but the winters tend to be warmer than normal and quite dry. And that's what we saw in winter of 20 into 21. Like we said, drought had kind of eased off in the region. You see there the drought monitor from August 31st, 2021. Western New Mexico, Colorado into Utah were still in pretty rough shape, but eastern New Mexico, which was part of the Southern Plains Dews at the time, as well as Texas, Oklahoma, and Kansas are pretty much free of drought. But when we look at just a month later, that's showing a change map on the center of the screen there. Drought deteriorated quite rapidly over Oklahoma, parts of Texas, eastern Colorado, Arkansas, and into Missouri there. Sometimes up to as much as 4 classes of drought degradation in northeast Oklahoma. So it onset fast. It's what we call a flash drought. And this really marked the beginning of a multi-year, multi-billion-dollar drought in the Southern Plains. On the right, you can see that drought monitor from September 28th, where we ended up at that time. As we moved through that fall 21 into early 22, during the summer is really when we saw the spatial expanse and severity of drought across the region reach its peak. On the screen there, you see August 9th of 2022, a good chunk of Texas is covered in exceptional drought or extreme drought, as well as Oklahoma, western Kansas there. So summer 22, we saw that those hot and dry conditions really intensified over the course of 22. August 9th was really when we saw that peak in severity and extent of the 2020 through 25 drought overall. It doesn't mean it's going away, but this was kind of the worst conditions that we saw in terms of intensity. This is showing that change map from August 22nd compared to June 7th of summer of 22. So we saw that drought conditions degrade across eastern Oklahoma, southeastern Kansas, and a good chunk of Texas saw degradations as well. Louisiana, New Mexico did see some improvement in this time, but this is where we were sitting at the end of August in 2022. Drought kind of waxed and waned over the course of the next year, never really reaching that full extent that we saw in summer of 2022. Summer 2023 was kind of the next big event in terms of the ongoing drought. We saw a flash drought happen in East Texas and western Louisiana. We'd seen a record-setting heat wave the previous June. That heat dome is shown there on the left. Really severe temperature anomalies up to 15 degrees Fahrenheit above average in some parts of West Texas. That flash drought in Texas and Louisiana led to the largest wildfire in state history for Louisiana. On the right there is a satellite view. You can see the fire there northwest of Lake Charles. And then some areas further south, there were pretty large burning events. And what's usually a pretty wet and lush environment, it's pretty swampy, a lot of bios. And they were drying out. Magnolia trees were reported as dying. I couldn't find a picture of that for y'all, but that area, that doesn't happen. So when those trees start dying, that means it's pretty substantially dry. And they saw that at the end of August in 2023, that large fire. As you can see, that was up to 4 to 5 classes of drought degradation across East Texas and Western Louisiana. The right is showing the drought monitor kind of at the end of that period, September 26. That exceptional drought really built in and continued and held on in the region through early winter. It did eventually subside, and we remained in drought for the rest of 2024 into 2025. As often in the region, droughts are often demarcated by a flood. They end with a lot of dryness, or they start with a long period of dry, usually ended by a flood event, or that can at least kind of get us the kick out of that event. We did see that across the region in June of 2025. A lot of folks on the webinar probably heard about the flooding in Central Texas at that time. West of Austin, that area received up to over 20 inches of rain over a pretty short period of time. Bertram saw up to 20 inches during that time period. With that, kind of big push of precipitation, moisture across the region, though, despite the tragedy associated with the flooding, it did kind of demarcate that 12-week period where the DSCI fell below that 100 mark. So that first week, using that 12-week metric, would indicate that the drought finally ended in June of 2025 after being continuously in drought from late 21 and in some areas since 2020. There were still some embers of severe drought in parts of the region. Big Bend, far west Texas, drought held on there. And we've seen through 2025 in the fall, drought re-intensifying across the region. So it's been quite dry out there, and drought has settled back in across the Southern Plains. And so that's kind of where we're sitting now. So is the drought over? Is it not? It doesn't look like it at this time, but we did have to come up with an end for the report. But we're continuing to monitor the situation, provide drought updates and webinar to the region, and see where it goes from here. So stay tuned. So here we're going to move in from that progression of the drought, kind of that temporal look at it, where we were looking at the intensity and the severity of drought across the Southern Plains, into the impacts. What did we see impacted from that drought during that period? One of the big ones is agriculture. We did see quite a few crop failures across the region over the period. This is highlighting 2022, which was probably the worst in terms of crop failure. The percentage of crops that failed in each state: for Kansas, it was about 9.5% total loss. Oklahoma, they lost about 30% of their overall crops. Texas, we lost half. We were right at about 50%, and that's measured by that total acres planted within each state, and then how many were actually harvested in the end. Total, that brings the region to just shy of 30% of crops failed in the summer of 22. So over the course of the drought, when it was severe in areas, we generally saw pretty severe impacts to agriculture. Failed crops. The wheat crop was pretty bad in Texas for a few years, as well as the cotton crop. Not just from the impacts to plants, though. Our region is a big producer of cattle for beef, and we saw some pretty heavy impacts to that. A lot of producers were still recovering from the previous drought from 2010, 2015. It takes a while to build the herd back up. So they hadn't really recovered from that, and then getting hit again. So we see there on the screen, the herd size in 2020 is shown by those light blue bars, and then the herd size in 2024. So Kansas didn't see as big of a drop off, say percentage-wise, as Oklahoma nor Texas, but each state saw a substantial decline in the number of cattle present in each state. One thing we did see with the drought in Texas, Louisiana, in drought-affected regions, we did see quite a few wildfire events. So dry conditions and abundant fuel loads from previous years, previous season growth, did contribute to several large wildfires throughout the region. Accompanying low stream flow harmed riparian ecosystems and led to a decrease in biodiversity that we're just starting to understand now as records are coming out. Reports from the last few years are entering the literature saw a decline in riparian biodiversity. Drought conditions also stress vegetation across the region. This affects grazing lands as well as natural wildlife habitats. When grazing goes down, producers have to haul water, feed their cattle, their livestock, and that does cost money as well as labor to get that out there. Also, one thing that we saw across the region and often do during drought conditions is dust storms. So on the screen is a picture from Goodwell, Oklahoma, one of our partners there with the USDA. Sent this picture from January 15th. You can see, not really see, it's obscured by dust, but you're seeing a field, a farm operation there, and it's almost completely obscured by blowing dust. So those are a feature usually during the winter, the non-active growing season. In the Southern Plains, we do see quite a few dust storms during drought periods. Drought also with a long-term lack of precipitation. People still need water, so they're drawing on groundwater and stream flow that's still there. Over the course of the drought, we did see water supply stressed pretty severely across the region. The Edwards Aquifer in Texas dropped into drought stages there. You look at 2022, the big decline during that severe summer, and it kind of stabilized at a lower level there, but has continued to drop. So that's the Edward Aquifer, which is a major aquifer in central Texas. Cheney Lake in Wichita, Kansas, there is shown on the screen. They entered stage 1 of its drought response plan in 2023. So drought response plans by a lot of municipalities and water districts were triggered over the course of this drought. A lot of aquifers saw declines in groundwater levels. So water supplies were severely impacted. Here's an example that's been in the news recently is Corpus Christi, Texas. Lake Corpus Christi has fallen below 10% of its capacity for the first time since it was filled as a reservoir. Corpus Christi is an area of Texas that has a lot of industry, a lot of oil refining, and they're dependent on water for those operations. So with Lake Corpus Christi dropping below that capacity, they're concerned about water for industry and for its citizens. So that's been in the news quite a bit the last few weeks. So keep an eye on Corpus Christi, and let's hope that the water situation doesn't continue there. Just trying to sum up the 2020 through 25 Southern Plains drought. As we mentioned, it was a complex multi-year event, and we saw it was characterized by rapid periods of intensification or flash droughts. Then we'd see a little bit of a partial recovery, and usually drought would intensify again the following season, kind of compounding the impacts over several years. The fluctuating severity of this drought, as opposed to 2010 through 2015, which was more uniform across the region, this fluctuating drought severity really presented unique challenges for resource managers. So at times, parts of the region were wet and doing great, others are very dry, and we kind of seesaw back and forth. Just to kind of sum some of the things we talked about up in terms of numbers, there were substantial costs to agriculture. It's estimated that the widespread crop failures that we saw, particularly as mentioned, those winter wheat and cotton crops, the impact from the drought through from 2020 through 2024 was over $23 billion in impact. We saw a reduction in cattle herd numbers, the lack of feed or pasture force ranchers to thin their herds and move their cattle to another state if that was an option. During the drought period, there were news articles about cattle auctions going into the early morning hours as they were just selling off a lot of cattle at one time. Pretty dramatic stuff. We saw that herd size change overall. So like we saw, Texas is down over 1 million head of cattle. Oklahoma is down about 600,000, and Kansas is down about 350,000. Those are substantial numbers for the herd size in each of those states. It also created significant water resource stress. Major reservoirs in Texas were near or at their record low levels multiple times over this period. This included some of those major reservoirs along the Rio Grande and in central Texas, such as Falcon International Reservoir, Elephant Butte Reservoir in New Mexico, Canyon Lake, and the Edwards Aquifer all saw major impacts from the 2020 through 25 Southern Plains drought. Here, I'm going to hand it back over to Joel to talk about comparing the 2020 drought through 2025 drought to 2010 through 2015.
Great, thank you, BJ, and good job summarizing the drought timeline up to this point. Part of the report that I'm going to be highlighting in the next few slides is this comparison of the present drought with the most recent drought, which happened in 2010 to 2015. Go ahead to the next slide, BJ. So here's a timeline from 1850 to 2025. Sorry, not 1850, 1895 to 2025 of the standardized precipitation index for the Southern Plains states. And there are a few notable droughts within this, but the key takeaway is in this box in the top right. The Southern Plains region has a long history of drought, and since 1822, when our records that are first flagging drought are credible, we see that severe drought has occurred in the region about once every decade. So there's a lot of droughts, and it's a place it's a part of the country that sees these regularly come up. Go ahead to the next slide. Looking at some of the impacts from the 2010 to 2015 drought compared to the 2020 to 2025 drought, one of the big ones was in the agricultural space. On the left, I'm showing a time series of the changes in cattle herd, which BJ already mentioned, the drop of over 1 million head of cattle in Texas in the 2020 to 2025 drought. Looking back at the 2010 to 2015 drought, we saw an equally large, if not a little bit larger drop. And the herd number hadn't restored to pre-drought levels yet when the next drought started. On the right, I'm showing statewide crop failures. The 2022 numbers BJ's already shown, but when you compare those with the numbers from the 2011 drought, 2011 was the peak of that previous drought period, they're in all states but Oklahoma, they're just a little bit worse. Oklahoma is pretty close to the same impact to agriculture from that earlier drought to the present one. Next slide. This is a graph I'm going to try to unpack a little bit so that we understand. So the dashed brown line is the drought severity coverage index, which BJ explained earlier. It's the index that we use to demarcate the beginning and end of this drought period. This is an annual average of that DSCI going back to the year 2000, when the U.S. Drought Monitor began. And the green line is the estimated cost of that drought for each year. And so you can see, looking at the 2010 to 2015 period, the DSCI values got higher than what they got in the 2020 to 2025 drought. But the cost of the drought was higher in this present drought compared to that earlier drought. And we had a lot of conversations, both amongst ourselves as we were writing this, but also with stakeholders as we were going into this process, about why this drought costs so much more, even if by the environmental measurements that we have, it wasn't quite as bad. BJ, can you click the button once? You might remember BJ, when he was talking about these listening sessions, most of the stories that we heard were about the successional impacts of drought and the lack of substantial recovery period between the last drought and this present drought. There was only 5 years between when the last drought ended and the current drought started. And people talked about the land being sick and not having enough time to recover. A few slides ago, I showed that the number of cattle hadn't returned to pre-drought levels when the next drought started. It's almost as if, just as land managers were getting back on their feet after the last drought, the carpet got yanked out from under them again, and they had to deal with drought all over again before fully recovering from the last one. Go ahead to the next slide. So next I'm going to talk about some of the key takeaways from this whole process. Next slide. As we're building resilience, what can we do to build more resilience to drought in the Southern Plains? And these are some of the lessons learned from this process of analyzing the drought. The first is to enhance drought monitoring for early warning. BJ mentioned when we were analyzing the models and how well they forecast this drought, the models lagged the observations, sometimes by a month and sometimes by up to 6 months. And having good observations and real-time observations across the whole region really gave us that ability to see drought changes as they were happening. And the more that we can do to enhance those observation sites and get as much value from that data as we can, it provides just as much early warning as looking at the forecasts. But the other lesson learned from this is that we can put some work into improving our seasonal forecast capability so that we're not relying just on observations, but we have some sort of foresight as to what changes we can expect in the month to 3 months ahead. Go ahead to the next. A few of the other lessons learned to build drought resilience is one is to develop comprehensive drought plans. And I want to say that throughout this drought, it was very clear that at a state level, Kansas, Oklahoma, and Texas all had drought plans in place and executed those when the certain trigger points were reached. And things went to plan very well at a state level. Many counties and large cities also had drought plans in place. BJ mentioned Lake Cheney in Wichita, and that there was a plan in place that when the reservoir levels hit a certain level, when they dropped to a certain level, that actions would be put in place to conserve water. But we also saw that some of the mid-level to smaller cities or counties didn't have these plans in place, and some places were not quite as prepared as others. One of the other things that could help us understand the connection between drying patterns and how they're impacted is to get a better collection of drought impacts, to understand how is the landscape changing, how much does the drought cost, what are the decisions people are making in response to those. Go to the next. Some of the other things that we learned is to educate stakeholders about the U.S. Drought Monitor and how that works and how that feeds into U.S. disaster relief programs. And also, how can we address future drought? We saw several periods of flash drought throughout this drought period. Those are usually triggered by really warm periods or heat waves that come through. And most of our model projections in the very long term suggest that these are going to become more frequent. So how can we address those in advance and be ready? Go ahead to the next slide, BJ. Okay, so that wraps up what we learned from this drought assessment. And that report was published in early December of last year. And now I want to shift gears just a little bit to talk about how drought has changed since we published that report. So go ahead to the next slide. So this is looking at winter from the beginning of December through the end of February this last year. And on the left, I'm showing the percent of average precipitation, and on the right is the difference from average temperature. So that's our anomaly. Throughout the winter, the weather included a late January cold snap. You might remember we had snow down in Dallas, freezing rain as far as Corpus Christi. It made the news, national news, about how cold this was. But when we look at the season as a whole, this was just a blip in what was overall a warmer and drier than average winter across the whole region. Go to the next slide. On the left, I'm showing a change map of how the U.S. Drought Monitor changed from the first week of winter in December through to the last week of winter in February. There's a lot of orange and yellows on this map. We can see areas where drought, after having ended in summer and started ramping up again in the fall, we can see that over this last winter where it was warm and dry, drought expanded again across most of Texas and Oklahoma and the southern border of Kansas. We still have parts of exceptional drought across the Big Bend area and along the Rio Grande, lower Rio Grande Valley. It's still very dry, and this winter has not been great for drought. We're looking ahead at hoping, well, we anticipate this to alleviate as we come into the wetter time of the year, but there's still a lot going on. Go to the next slide, BJ. This is still looking at those winter months of December through February. On the left, the yellow or orange lines, this is our temperature for each state. So Kansas on the top, Oklahoma in the middle, and Texas on the bottom. On the right is the same, but for precipitation. And that's just a way to visually see how some of how the winter played out. For Kansas, it was the second warmest winter on record and the 34th driest. In Oklahoma, it was the warmest winter on record and the 7th driest, and down in Texas, it was also the first warmest winter on record and ranked as the 5th driest. Go ahead to the next slide, BJ. So that wraps it up for me. I'm going to pass it back to BJ to talk about forecast, what we anticipate drought, how we anticipate drought to change over the next few months.
Yeah. Thanks, Joel. So yeah, as Joel mentioned, he gave an overview of what's happened this winter so far. So for the region, as he showed, was quite warm and quite dry. I wish I had good news with the upcoming forecasts, but let's look at the next 2 weeks. So about 2 weeks out, so the 8 to 14 day temperature outlook for most of the Southern Plains region there, you see a lot of red. What these are, they're what we call tercile-based probabilistic forecasts. So the warmer colors don't necessarily respond to more above normal temperatures or hotter temperatures. They respond to probability of above normal temperatures. So what we're seeing here across far west Texas, out by El Paso, we're seeing about 70 to 80% chance of above average temperatures at that 8 to 14 day temperature. It does decrease as you move east and north, but most of the region is still forecast about 50 to 60% chances of above normal temperatures in the eastern part of the Southern Plains. Correspondingly for temperature, most of the Southern Plains is showing to be near normal or have a likelihood of above normal precipitation. So across central and south Texas, they have a better chance over the next 2 weeks of seeing some rainfall. So that's good news. North Texas, Oklahoma are near normal, as is about the southeastern half of Kansas. But if you look at northwest Kansas there, they got a 33 to 40% probability of being below normal precipitation for the next 2 weeks. So looking still warm and potentially dry in the northern part of the region, might be a little wet here in the south. Looking a little farther afield though, these are seasonal outlooks. So these are for 3 months. So this would include March, April, and May. So part of this month already, and then the rest of April and then the rest of May are included in this outlook. On the larger scale, we're seeing the current La Nina event that we're in the equatorial Pacific weaken. So we should be entering neutral conditions soon. Generally in the winter, we look for neutral or El Nino conditions having a higher chance of above normal precipitation. Unfortunately for the summer, it kind of goes the other way because El Nino events decrease tropical cyclone activity. So we're looking at potentially having fewer tropical systems this summer, which are a big supplier of rain to the eastern part of the region. For the next 3 months, though, we're looking at higher chances of above normal temperatures across the region, kind of increasing as you move towards the southwest. And then for precipitation, the eastern part of the Southern Plains largely showing equal chances. So the models aren't really queuing in on wet or dry for those months. But if we look at the western portions of the region, we see those escalating brown colors, and that would indicate higher chances of below normal precipitation over that 3-month period for the western part of the Southern Plains. So still looking quite warm out there and potentially pretty dry. As we look a little further ahead, I think, Joel, were you going to talk about ENSO here?
No, you can do it.
I'm going to do this. Okay, I got it. Sorry, all. So with ENSO, this is showing the official NOAA forecast from the Climate Prediction Center on ENSO probabilities. So ENSO uses a 3-month average of surface seawater temperatures in the equatorial Pacific. You showed that FMA, that'd be February, March, April on the left side of that screen, showed that we were likely transitioning to neutral conditions by March, April, May. We're expecting those neutral conditions to have fully emerged. And as we move through the year, we see that probability of an El Nino event go up as we transition into next fall and early winter. That could be potentially good news if the El Nino comes through, because in the winter in the Southern Plains, El Ninos are generally associated with above normal precipitation and slightly cooler temperatures. So the long range potentially looks promising, but the short term, we're still going to have to deal with some ongoing dryness across the region. And with that, I think we're going to have time for any questions that have come up, but I wanted to say thanks for attending the webinar. You can access the report at that QR code, or I think I saw Eleanor drop that into the chat, so you can follow that link. And yeah, with that, Joel, I think we're ready for questions.
Yeah, thanks, BJ. That was great. I also, so in addition to the link that's in the chat, I also just dropped a link to a drought.gov article talking about how ENSO will likely impact or could impact drought conditions in the Southern Plains as we look ahead. So if you're interested in that, go ahead and follow that link. And yeah, either click the link or follow the QR code to read the full report. There was one question come through so far Again, I'll remind the whole audience, if you would like to ask a question, go ahead to the Slido app. If you're on the web browser for WebEx, if you've joined us through a web browser, you have to click on the apps button first and then open Slido. But if you have opened the app, the WebEx apps, you have access to Slido right away. And BJ, can I just check? Can you see the questions too?
Yeah, I can.
Okay. So that's great. So we'll just take the questions as they come in. The first question is about the Ogallala. We know the Ogallala is impacted by pumping, and we were asked if we had a graph of the drought impacts on that. We don't. I did not prepare a graph for the Ogallala, and it's a little bit hard to tease out the impacts of just this one particular drought on the overall rate of decline of the Ogallala aquifer. It's a part of the country that's semi-arid, and people rely on the aquifer whether it's drought time or not. And we assume that people are using more water during times of drought, but there wasn't really a clear signal looking at the rate of decline during this drought period, that we didn't include that in the report. But great question, though. It certainly is a part of the country where we're paying a lot of attention to what people are doing there and how much water is left in that aquifer as a water resource and even a drought mitigation.
Yeah.
So thank you for that.
Yeah, I'll just add on to that too. So the Texas Water Development Board is a state agency here in Texas. They have on their website some resources looking at well depth and things like that, stream flow. They could have might have some information on wells in the Ogallala there. What I will say is my work in Texas with the Office of the State Climatologist, we work with producers up in the Panhandle that are largely dependent on groundwater for their operations. The situation's looking pretty dire up there in terms of long-term sustainability of the aquifer. So it's something a lot of people are looking at and trying to find ways to conserve what we have left for those areas, because the depth of the aquifer varies quite a bit across the region. The deepest parts, if I remember right, are up over central Nebraska in the Sandhills, but it extends down into Texas where it's quite a bit shallower in the Panhandle.
Eleanor just shared a link to the Texas Water Development Board. Thank you, Eleanor.
Thank you.
Any other questions that anybody would like us to talk about? Feel free to ask those now. PJ, I might ask a question of you while we're waiting for other questions to come in. So when we started this process of analyzing the Southern Plains drought, you were relatively new to Texas. You just finished up in Nebraska and had come down to take this position at the Southern Regional Climate Center. Was there anything that surprised you as you were talking to stakeholders and putting together data for this report?
Yeah, so not quite Nebraska. I actually came from Michigan to Texas. I was in Nebraska before that. So then that's part of my response here too, which is why I pointed it out. So no worries on the process of my location. But coming to Texas from the Great Lakes was kind of going 180 degrees the opposite way in terms of soil water management and the things I worked on as part of my research. The Great Lakes is an area where drought doesn't really get discussed all that much. They do see droughts, but they're generally not as severe or intense as what we see down here in Texas. Generally, people there have too much water and they're trying to figure out what to do with it and how to drain things so they can farm and the like. Coming to Texas, it's 180 degrees the other way. It's how can we keep that water in the soil? How can we use less water, get a bigger return? It's the complete opposite side of the coin. So that's been interesting in getting that together.
Yeah, thanks for that perspective. We had it's a comment that came through. It was sort of a question comment, and it's about some of the data that we use. So thanks for asking this. It says, would we consider using Farm Service Agency rather than the NASS data for crop estimates? And then there's some details about how there's some overestimating and possibly underreporting in the NASS data. Yes, I think anytime we can get better or more accurate data than what we knew were available at the time, that would definitely help connect the dots between environmental drought and the impacts to people and especially agriculture for that. So I might follow up with the person that asked that question after this webinar and see if we can talk about getting some better data to give us a better idea of what actually happened and what the impacts are. So thanks for that information. That's really useful.
Yeah, I'd agree. Though those are known problems with the NAS data. So thank you for bringing that up. Generally, FSA is higher quality. It deals more directly with crop insurance and things like that.
I might give it just a few more seconds before we wrap up. If there's not any more questions, we can finish the webinar where it is. I'll pause to give any last minute slow typers maybe a chance to ask. And if nothing else comes through, I might finish it up there. BJ, do you have any last minute thoughts or comments before I finish the webinar?
No, nothing really from my end. So just thanks for attending. Thanks for the questions. It's good to see this info get out there.
Great, thanks. I echo that. Thank you for attending. I really appreciate you making some time and coming along and listening to this. And if you want to dig down into any more of the analysis we did, have a look at the report, and this webinar will be posted on drought.gov later this week. So that will end today's webinar. Thanks again for attending, and I hope you have a great rest of your day.
Thanks, everybody.